Hello my dear students, in our last video we discussed about these Lorentz transformation equations and inverse Lorentz transformation equations. So on the basis of these equation, today we continue our discussion about the new topic, length contraction. See, the shortening or decreasing in the length of an object along the direction of the motion. Important point, shortening or decreasing in the length of an object in the only direction of motion. If the object is moving in x direction, we consider only x direction, is known as length contraction. According to Lorentz transformation equations, the moving object is contracted along its direction of motion. Whatever I said already, if it is x direction, it contracted along its direction of motion, only direction of motion, and remains unchanged in perpendicular directions. Note down this point, remain unchanged in perpendicular direction. Now consider two coordinate systems s1 and s dash. Let s dash is moving with an uniform velocity v in a positive x direction. So direction of the motion is x direction relative to the frame mass, which is at rest. The s dash is moving with a velocity v relative to s, it is at rest. Consider a rod AB. Now consider a rod AB at rest with respect to s dash frame. Let x1 dash x2 dash be the end coordinates of the rods as measured from s dash frame. x1 dash x2 dash in the s dash frame. Hence its length is, coordinate system s dash is, the length is given by L0 is equal to x2 minus x2 dash minus x1 dash, x2 dash minus x1 dash. Similarly in this, x2 minus x1 is equal to t. Here similarly x1 and x2 be the ends coordinate of rod measured from s1. For s1, the same rod have coordinates x1 and x2. For that, the length of the rod in S is given by L is equal to x2 minus x1. This is equation number 1 for S dash. This is equation number 2 for S. Now we already know this Lorentz transformation equation. According to the Lorentz transformations, we know this x1 dash equal to x1 minus vt divided by square root of 1 minus v square by c square. Similarly, and this is equation number 3, and x2 dash is x2 minus vt divided by square root of 1 minus v square by c square. This is equation number 4. These equation 3 and 4 we substitute in equation number 1. We get, see, L0 is equal to, this is equation number 1, 3 minus equation number 4. The denominator is same, so we write this x2 minus vt minus x1 minus vt, plus vt minus vt is get cancelled. The remaining term is x2 minus x1 divided by 1 minus v square by c square. This from equation number 2, L equal to x2 minus x1, right? Then write this value here, L not equal to L divided by square root of 1 minus v square by c square. Now alter this. This divided by term is getting this side. So L is equal to L naught into square root of 1 minus v square by c square. This is equation number 5. This equation number 5 clears that length of the rod appears to be different when observed from the different frames. See, L and L naught are both are different. By this term, the length of the rod moving with an velocity v relative to the stationary frame is shortened by the factor here, square root of 1 minus v square by c square. It's shortened by this term in this direction of the motion. Now, example for this length contraction. See, a body which appears to be spherical at an observer at rest. See, when at rest, the circle looks like a circle. The shape of the circle looks like a circle. When it moving with a speed, velocity v, it appears like an ellipse. This is one example. The best example is car tires. And now, see, another example is similarly a square appears to be the observer in the other frame as rectangle. This is at rest frame, it looks like a square. At moving frame, it looks like a rectangle. And now for this length contraction, some important points is there. See, note the proper length of an object is the length determined by the observer at rest with respect to the object. In the above case, L0 is proper length. So the L0 is called as proper length. The shortening or contraction in the length of an object is along the direction of the motion only. I already said that the length contraction of object is only along direction of motion. If it is moving in x direction, in only x direction. If it is moving in y direction, only y direction. There is no contraction in the directions perpendicular to the direction of the motion. I already said this. The contraction became appreciable when v means velocity nearly equal to the c, speed of light. The last note is the contraction is reciprocal. See here, if two identical rods are at rest, one is in S and another one is S dash frame, each of the observer finds that the other is shorter than the rod and his own system. See that last note said that if the person 1 is here, person 2 is here, both the rods, this rod is shortened for him, this rod is shortened for him. The last note said about this. See here, vice versa. If two identical rods are at rest, one is an S frame and another one is S dash frame, each of the observer finds that the other one is shorter than the rod and his own system. This is last note. This is about length contraction and some important notes of length contraction.